Why are some muscles built for endurance, while for others, they're built for strength? Here's how those muscle fibers work. There are three types of muscles in the human body: smooth muscle, cardiac muscle, and skeletal muscle. Now, skeletal muscle is the only one of these three that is under our voluntary control. It is the type of muscle that's responsible for force production that causes movement, breathing, and stabilizing the joints. Skeletal muscle is divided into two fiber types: fast twitch and slow twitch, and they differ between maximum force production, speed of contraction, and fiber efficiency. Starting with type 1 fibers, aka the slow twitch fibers. They're very fatigue resistant and have a high capacity for aerobic exercises, and that makes them perfect for any prolonged endurance activities like long distance running and cycling. They also have a high concentration of myoglobin, which is a protein that stores oxygen, and that allows for sustained oxygen delivery during the prolonged endurance activities. Type 1 fibers also play a crucial role in maintaining posture and stability. Their sustained contraction helps support the body against gravity, making them essential for activities like standing and maintaining an upright position. However, when compared to type 2 fibers, they have lower fiber-to-neuron ratio, as they have 10 to 180 fibers per motor neuron. They also have a relatively slow contraction speed of 110 milliseconds to reach peak tension. This makes their contraction much slower than fast-twitch fibers, but it is a characteristic that is beneficial for maintaining muscle function over extended periods and activities requiring prolonged muscle engagement. Moving on to type 2 fibers, aka fast-twitch fibers, they are prone to fatigue, but they have high motor strength and a high capacity for anaerobic exercises. This makes them ideal for short, rapid, and powerful contractions because they're well suited for any activity that requires a burst of strength, like sprinting and weightlifting. They also tend to look whitish in appearance when compared to type 1 fibers, and that's because a lower concentration of myoglobin and blood supply. This color difference is often used as an easy way to differentiate between type 2 fibers and the more reddish appearance of type 1 fibers. Interestingly enough, type 2 fibers have fewer mitochondria when compared to type 1 fiber. This highlights their decreased capacity for aerobic energy production and their dependence on other pathways to generate energy in short bursts of intense activity. Type 2 fibers also have fast contraction speed of 50 milliseconds to reach peak tension, much faster than type 1 fibers. This coupled with high motor neuron efficiency, as each motor neuron in type 2 fibers innervates 300 to 800 muscle fibers, leading to high fiber-to-neuron ratio. This efficiency supports the coordination of rapid and precise movements and overall results in quick and powerful actions perfectly suited for activities like jumping, sprinting, and weightlifting. Now, whether it's the marathoner's endurance or the sprinter's speed, understanding the dynamic between type 1 fibers and type 2 fibers reveals how the muscles adapt to our physical demands. For example, sprinters and weightlifters possess a high percentage of type 2 fibers, usually around 60 to 80%, while endurance athletes such as cyclists and marathon runners possess a high percentage of type 1 fibers, and that's around 60 to 70%. And that's why some muscles are built for endurance, while for others, they're optimized for strength.